Hey everyone, I'm Gene. Welcome back to another episode of our Java Deep Dive. Today we're going to take our understanding of multithreading to the next level. We'll be exploring three crucial concepts: thread states, thread priority, and thread interruption. If you're new to multithreading or haven't seen my previous video, I highly recommend you checking it out. It'll give you the foundation you need to really grasp these advanced topics. So let's dive right in. First up, let's talk about the different states a thread can be in. Imagine a thread as a little worker. It can be new, just born, ready to start; runnable, actively working, doing its thing; blocked, stuck, waiting for something like a log or a resource; waiting, impatiently waiting for a specific event; timed waiting, impatiently waiting for a specific event but with a timeout; terminated, finished its work, ready to retire. We can use the isAlive method to check if a thread is still running, and to find out how many cores your system has, you can use runtime, get runtime, available processes. Alright, let's create a new method, state example, and also print the same thing to the terminal, state example. Now let's create a new class, sprinter, and extend thread. The class will have two parameters, name and step time, and both will be set within the constructor. Let's also create a new method, getSprinterName, to return the name. Now let's override the run method. Within this run method, we create a for loop with 10 steps, from 1 to 10, and in every step we sleep for a certain amount of milliseconds, set in a step time variable. Now let's go back to the app class and create a couple of sprinters, a Steve, a Chuck, and an Eddie. They all have different step times. Steve is at 250 milliseconds per step, Chuck at 650 milliseconds, and Eddie's a bit faster at 150. Now let's create a new coach class, which also extends thread. Here we create a private list of sprinters, which will be set in a class constructor. Now let's override the run method. And the first two things we want to do here is announce when the coach starts watching and when he stops watching. Now we are ready to create a while loop, which depends on a Boolean variable running sprinter exists, which we start by setting to true to enter the while loop. And the first thing we do is check if all sprinters are done. We do this by pulling a stream of the sprinters list, and then we check for any match in the list of a thread that has not the state terminated. In any other case, we return true, meaning that the while loop will continue. Now let's concentrate on printing the status. Here again we access the stream of the list. This time though, we make use of the map method, which loops through every thread and gets the sprinter name, adds a slash, and gets the current state. After that, we make use of the collect method to collect the results of the map method and join them by comma and blank. The result is one line of information of all the threads, which we can then print using the printf method, printing out coach node and then the line. After that, we limit the coach checking speed using the thread sleep method, and we will set it at 500 milliseconds. That's all for now for the coach class. Let's return to the app class and create a new coach providing the list of sprinters that we have, which is Steve, Chuck, and Eddie. Now we start the coach, then we use join to wait for the coach to be done, and after that we print the race is done. Well, until to this point, other than the coach watching, we didn't really do much, did we? Therefore, let's also start Steve, Chuck, and Eddie and run the application. And here we can see that they all start running. At the very beginning, before they start running, they have the new status. After that, we see that they have the timed waiting status, which corresponds to the thread sleep they have between each step. Once they are done, they get the terminated status. And here you can see that the coach needs to check 5 times until Steve is done. With Chuck, it's a bit more, it's 10 times. With Eddie, it's a bit less, it's 3 times. And with Chuck, it takes a bit longer. Once they are all terminated, the coach stops watching as well. And the race is done. Now we can also have the coach check for isAlive. So let's quickly add this line to the map method in the coach class and run the application again. And here we can see that at the beginning all the threads are false. And then while they are doing something, they are true. And once they are all terminated, they are false again. Now until to this point, all the sprinters are running in parallel. They all run at the same time. What we can do is transform this race into a relay race, meaning that first Steve runs, and once he's done, Chuck runs, and once he's done, Eddie runs. This can easily be done by making use of the join method. Once for Steve, then for Chuck, and then for Eddie. and then running the application again. And here you can see that first Steve is doing his job, while Chuck and Eddie still remain in a status new. Once Steve is terminated, Chuck starts to run, while Eddie still remains a new. And once Chuck is terminated, Eddie starts to run. And then again, when all the sprinters are terminated, the code stops watching. And the race is done. Now in our simulation of the sprinters doing something, we actually put them in a thread sleep. And this is the reason why we see timed waiting. But we can also give them a real job. So let's go back to the sprinter class and add a new method, calculate pi. And what this does is actually calculating pi. We can limit this by a number of iterations, which we can pass as a parameter. So let's add an if statement to the run method to only run the thread sleep code if the step time is set to more than 0. In the other case, we run the calculate pi method and set it to calculate 10 million iterations. Now let's go to the app class and comment out the 3 sprinters that we created before and create 3 new ones, but this time with a step time of 0, so that they run into calculating pi. Now let's run the application again. And here you can see that while they are doing their job, we don't see timed waiting anymore. We now see runnable. Next, let's talk about thread priority. Think of it like a priority queue. Threads with higher priority get more CPU time. However, the exact scheduling behavior can vary across different operating systems. Let's take a look at how we can set priorities in Java and how it might affect thread execution. We'll also dive into a practical example to illustrate this concept. Quick tip. While thread priority can be useful, it's not always the most reliable way to control thread execution. Sometimes other factors like system load and scheduling algorithms can influence the actual behavior. So for this example, we create a new method priority example and also print the same priority example. And we also make use of printf to print the number of processes using runtime, get runtime, available processes. Now we have 3 steps. Create printers, start printers, and print sprinter status. For creating the printers, we create a list of sprinters, making use of array lists. After that, in a for loop from 1 to 100, we create a new sprinter, providing the loop iteration as a name, and as a step time we use 0, so that the printer calculates pi. Then we use set priority to set the minimum priority using thread min priority, but we don't want to set it for all the threads. Let's only set it for the first 10 threads, and all the other 90 threads get the max priority. Lastly, we need to add the sprinter to the list of sprinters. Now let's start the sprinters, using a for loop and then start all the sprinters. To print the sprinter status, we create a new Boolean variable, unfinished threads, and set it to true. We use this in our while loop, where the first thing that we do is to set the unfinished threads variable to false, and then we create another loop, a for loop this time, to traverse all the sprinters and check the state of every sprinter. If it's terminated, we print a dash, and if it's not terminated, we print an O. In the case that it's not terminated, it also means that there are unfinished threads, meaning that unfinished threads is true. After checking all the threads, we print a new line. And after that, we make use of thread sleep to limit the number of checks we do in a certain time frame. Let's set it to 500 milliseconds. Now let's go to the main method and comment out the state example method and put in the priority example method. Now we are ready to run the application. And here we can see the 100 running threads that we created. And every 500 milliseconds we check for all of them. Remember that we set the first 10 threads with a low priority and the 90 other threads to a high priority. Well, here we run this application in Linux. So this might influence the result due to the scheduler. Personally, in this experience, I cannot really see which of the threads has had a higher priority than the other one. So let's run the same thing on Windows. Here it is a different scheduler doing its work, and I think we can see that there is a difference here. The 10 first threads were run a bit later. Let's see how this same code example behaves on a Mac. Again, we have a different scheduler, and here as well, I cannot really see that the 10 first threads were handled any different than the other ones. Finally, let's discuss thread interruption. This is a powerful mechanism to gracefully terminate a thread. However, it's important to note that a thread must be cooperative to be interrupted. It needs to periodically check for interruption requests. We'll explore how to interrupt threads, how to handle interruptions in your code, and the potential pitfalls to avoid. Remember, interruption is a request, not a command. A thread can choose to ignore the interruption or handle it in its own way. Alright, for the interruption, let's create a new method, interruption example. and also print the same thing, interruption example. Let's start by creating a new runnable with an anonymous method and override the run method. The first thing we want to do is get the name of the thread. Then we also want to define a variable count of type long, which we set to 0. And then we also want to define a Boolean variable, interrupted, which we set to false. And this is what we use for a while loop, which will run as long as interrupted is not false. And in every iteration, we add 1 to the count variable. After the while loop, we also want to use the printf method to print the thread name and the value of count. Now in every iteration within the while loop, we also want to check if an interruption has taken place. And if yes, we set interrupted to true. Now let's create 2 new threads, T1 and T2, and provide the runnable as a parameter. After that, we run both threads using the start method. Then we set the main thread to sleep for 1000 milliseconds. And after that, we interrupt T1 and T2. Alright, let's quickly comment out the priority example method and add the interruption example method that we just created. Now let's run the application. And here we can see the result, where after 1000 milliseconds, thread 1 counted until 3.5 billion and thread 0 counted until 3.4 billion. Now, with interruption we need to be a bit careful, because it might not always behave as you expect it to. So let's go back to the while loop and add thread sleep of 800 milliseconds. And because this may run into an interrupted exception, we put it into a try-catch context. And if we run into the catch context, we print the stack trace. Now let's run the application. And here you can see we run it, then we send the interruption. And if the interruption request takes place during the thread being in thread sleep, we actually catch the exception and just continue running after that. So we need to handle this a bit differently. So let's go back to the try-catch context, and instead of printing the stack trace, we set the variable interrupted to true. Now let's run it again. And there we see, this time it handled it gracefully. Both threads counting until 2. So there you have it, a deep dive into thread states, priorities and interruptions. By mastering these concepts, you can write more efficient and responsive multi-threaded applications. Don't forget to like, share and subscribe for more advanced Java content. In the next video, we'll dive into the world of thread synchronization and monitor logs. Let me know if you have any questions or if there's anything specific you'd like to see in future videos. Until then, happy coding!